are factoring, but we're getting into something different. So this is worksheet A48, and we're going to get into factoring by grouping. Now we're starting off with something pretty basic to introduce this idea. It just says to factor. Every time you look at something to factor, we want to look for a GCF. So what's the GCF of these two terms? 1. Okay, I can take out a 1 of anything, but that's not going to help change it. What else do you see? A y. So if you want to do a 1 with the y, that is fine with me. Now, when you take out this y, remember we showed dividing out each side by y? What's left? 3x plus 4. All right, that's it. That was the GCF. It got pulled out front. And if we would redistribute y times 3x, y times 4. Look at the next one. What's the GCF of these two? A 1, anything with variables. A 1z or just a z. Okay, now that we have that, what's left? X squared minus 5. We took the z out of each of these. Okay, now look at example 1.
48. Thanks, Katie.
If you look at this, there's a lot going on, but I want you to focus on these two pieces, 1 and 2. What do they both have in common? It's a little bit different, but what do they both have in common? What's in parentheses? Do you see that? Okay, now look at this first problem here. It's 3xy. There's 3x times something. This is 4y. It's 4 times something. So what I want you to see is these problems are the same, but instead of having a y, we have this in parentheses as s plus 5. Just like you took the y as the GCF and you put it out front, you're going to take this s plus 5 as the GCF and put it out front. And then whenever you divide by the GCF, you put what's left in parentheses to redistribute. So this stays in parentheses. I'm going to rebuild this in parentheses to distribute. That is the abstract part of what we're doing today. So when you look at this, you're taking the s plus 5 and distributing it to the 3x. You get right back to here. And you're taking the s plus 5 and distributing it to the 4 and getting back to here. That's it. You have factored a binomial. This is what it said, factor out the greatest common binomial factor. Here we factor out a monomial, 1 term. Here there's 2 terms. All right, now look at the next problem and compare it to this example B up here. If you look up here, I had x squared times z. Here I have x squared times x minus 10. Then I had minus 5z, and here I have minus 5 times x minus 10. Do you see how I took something that we're used to, something that was pretty basic, and we changed it to something more abstract? If you look at these two terms, I know there's a lot going on, but these are 2 terms here. What do they both have in common? Both of these pieces, 1 and 2, have the x minus 10 in common. Once that comes out, what would I have to remultiply it by? X squared, then minus 5. Okay. Again, I know it's a little abstract. So if you think about this, you have to see that these are 2 pieces being added or subtracted. This is the same for both of those pieces. It's my GCF. When I pull that out front, I would redistribute the x minus 10 to x squared and redistribute the x minus 10 to negative 5. Okay, now example 2, similar, but there's a little bit more stuff going on. So look at example 2a. You still have 2 pieces, 1 and 2. What do they have in common? They both have x plus 2. When I take that out, what would I have to remultiply it by? 2a squared b plus cd squared. Yep. So I can't stress this enough. This stays in parentheses, and it was the GCF. It got pulled from both, but if we redistribute and redistribute, that's why it needs multiplied. When you look at this next one, again, there's a lot going on. There are 1, 2, 3 terms here. Do you see 3 terms this time? What do they all have in common?
X in parentheses, x minus 1.
Okay, all 3 of them have x minus 1 in common. If I take the x minus 1 out of all three of them, what's left? X squared minus 13x and then plus 49. So that one's a little different, but I would need to take this chunk, x minus 1, this binomial, times the first term, times second term, times the third term, and I would get back to there. Okay. Are we seeing this okay? Are we okay and comfortable how this answer is being written? So we're going to go into the next step onto the back. First thing I need you to do every time you see the word that you're supposed to factor, I do need you to look for a GCF.
We're 48 today, right?
Maybe. So is there a GCF here for all four terms? 5, 5, no. Okay.
No.
So no GCF. I don't need any help with that part. Now, whenever you're doing this and you're not using photomath, anytime you go to factor by grouping, you're going to do 2 things in one set and 2 in the other set with a plus sign always in the middle. All right, so here's the deal. They don't have a GCF, and there's nothing I can do with them as they are. Now, some of you look at this first one. The 25x and the 3x are like terms. I don't want to put them together. It does say factor by grouping, so I don't want to put them together. I want to group it. So group the first 2. Plus sign in the middle, group the second 2. Why is that plus sign so important? I'm not multiplying. The original problem was that I was adding everything. If you ignore this plus sign, it looks like you're supposed to FOIL, and we're not doing that. Okay, now, when you multiply everything out, which we already did. Now, looking at the 2 groups, I'm going to ignore one group, and I'm going to focus on this. So, first, you look for the GCF of everything. There isn't one. So we grouped it, plus sign in the middle. What does the first set have in common? So we couldn't do anything with all 4, so we're looking at each group. They both have a 5 and a what?
X.
5x. Now, if I take out a 5x, what's left? X plus 5. This is why we spent our time on factoring. Okay? This is why we spent so much time. So 5x squared, 5x times 5 is 25x. Now, I'm going to cover this up and focus on this. I'm bringing down my plus sign. What do these 2 have in common? The 3x and the 15? They don't divide by 5. What do they divide by? 3. Now, if I take a 3 out of both of these and divide, what do I have? X plus 5. So, do we see that it goes from here and it goes to here? Now, we are back to where we were on the front of this paper. We are back to having these 2 pieces, and what do they both have in common?
The underlines.
What they have in common is the x plus 5. Take this out like you brought out on the front, and what would I have to remultiply it to? The 5x and the plus 3. So we went from this step to the last factoring on the front, but now here we backed it up to see where the step came from. All right, look at your next one. Is there a GCF across all 4 pieces? Just a 1. So that's not going to change anything here. So the next thing I'm going to do once I look for a GCF is I'm going to group it. First 2, second 2, what always goes in the middle? Always a plus sign. Okay, if it helps you to focus on one piece at a time, what do these 2 have in common? 6 and x squared, right? I want to take out the GCF. Then I'm left with x minus 1. So the idea here is if everything does come out, you need the 1 as a placeholder. So 6x squared times x, 6x squared times negative 1. Now, look at the second set of parentheses. I'm going to bring down my plus sign. What do these 2 have in common?
X.
I can't take something out of an x and a negative 1.
Parentheses.
But you will take out the 1. And you'll be left with x minus 1. So normally I tell you don't worry about factoring out a GCF of 1. But in a problem when you're grouping, that 1 is a placeholder. So it's actually really important. So I'm going to put a little star there, and that is your placeholder. Okay, now we're back to where we were on the front. What do these two chunks right here have in common? X minus 1. Once I factor that out, what's left? 6x squared plus 1. If you don't see this, you're thinking, where did they get these numbers? But if you see it, it's quite simple. It just depends on if your brain's picked it up or if you're paying attention. So again, these both have the x minus 1. It comes out front. If I would take this and redistribute it, I get it back. If I take this, redistribute it, I get that piece back. All right, look at the next one. Is there a GCF? All right, is there a GCF on here? I was going with 4, and then I realized I can't take a 4 out of everything. Anything else work? All right, so when I have 4 terms, I'm going to group them and work with each group's individually. So I'm going to cover this up. And what's the GCF of just these two? I actually said 4, right? Anything else with the 4? A 4x. All right. What's left? 3x minus 5y. Okay with that? So we're doing 2 very small GCF problems that come together to make a big problem. Greatest common factor. Now, what do these two have in common? A 5 and a y. What's left over? Okay, now for some of you, if it helps you, you can put that little divided by 5y under each of these. And so there's the 3x because this cancels, and there is the minus 5 with 1y. Now, if we look, there are 2 terms here. What do they have in common? Again, what's in parentheses? It's almost like it's circled for you. Did you catch that? They both have the 3x minus 5y. Once I take that out, what's left over? 4x plus 5y. So if you're trying this problem, and I'm actually going to do it in pencil because I know this, and you wouldn't have known this, but I know this isn't going to work. So if you jumped in and said, hey, there's no GCF, and you group it, and you don't have to write this right now because we're going to have to redo it. If I take out, there's nothing to take out. Now the leading term is negative, so maybe I take out a negative 1. What's left is positive 2a squared minus 5cb plus, does anything come out of these two? So I would take out a 1. I have to take out that 1. But then I have 5ca squared minus 2. Do these 2 pieces have anything in common? No. I actually can't factor this one grouping in the way it is. Now, if you listen to me, I did say you did not have to write this because I was going to have to fix it. So I am going to have to restart this problem. Okay. So the idea is the pairing of these first 2 terms didn't work out. So we're going to rearrange it. So sometimes you have to rearrange a problem. So I'm going to let you pick. I need to move things around. So you want to keep the negative 2a squared first, or do you want to pick something else to go first? Your choice. It can work any way. Okay, what do you want to go first? Okay, 5ca squared. Now, if I have the 5ca squared first, what could I pick to go with it that would have something in common? Well, obviously not the minus 2b, right? Because that pairing didn't work. So if I pick the 5cb, that's good, or I pick the negative 2 because it has an a squared. Your choice. Which would you like? We can rearrange it a couple ways.
5cb.
Okay, so we're going to pair these 2 up. That's what you want to do? 5cb. And then what else do I have? Minus 2a squared minus 2b. So here's the idea. you could rearrange this differently than your neighbor, and that's fine as long as you make sure when you rearrange it they have something in common. This is the one arrangement that didn't work. Now, when I get into factoring this, I am going to group it, but notice what's in the middle if I put this parenthesis here. A minus sign. Now pay attention to this, and I'm going to erase this here in a second. This minus sign only belongs to the 2a squared. Do we agree? It does not change this one. If I put the parentheses here, mathematically, doesn't this negative sign distribute and change this to positive 2b? Okay, that's why I said at the beginning what always has to be between your parentheses. Would always need to be between your two parentheses when you group. A plus sign. So here's how I solve my issue. I'm going to squeeze that minus sign in with what it belongs to. I'm going to put my own plus sign in the middle. Okay? Are we good on that? Now, go back to what we've been doing. Cover this. Does this have a GCF? Of 5c. What's left? A squared plus b. So I divided both these by 5c. Now, bring down your plus sign, because this is not multiplication. This is adding still. What do these two have in common? A 2. Now here's the deal. If I take out a 2, that leaves me a negative with the a squared and a negative with the b. What's wrong with this? I've got these two pieces, but is it the same? What's in the parentheses? They're not the same. What's different? The signs are the opposite, right? So instead of taking out a 2, remember I kept telling you when the first term is negative to practice taking out a negative sign? So if I take out a negative, this divides out and becomes a positive a squared, and this negative divides by negative 2 and becomes a positive b. So signs are going to be important here. And now that we have that, now is it the same what's in parentheses? It is. So what they have in common is that a squared plus b, and what they have left over is 5c minus 2. What's an a? All right, am I good? Now, let's take a side step, and please don't ignore this. Let's say we didn't arrange it the way you gave me, okay? Let's rearrange it another way. Let's go with, I don't know, maybe we'll make the 5cb paired with the negative 2a squared, and then we'll leave a negative 2b here and the positive 5cb. No, you don't have to write this, but I do want you to look at it. What does this need to be?
Needs to be
5cb. I can't pair that together. Look, I can't pair these back together. I know, that's embarrassing. Let's change this. We'll make this the minus 2b. And then I'll make this the negative 2a squared. And then the what? Minus 5c squared. I was trying to make it different and I screwed it up. Okay, let me restart here. I put the 5cb first, and I paired it with the minus 2b because they both have b's. And then these both have a squareds. Do you see how I did that? So if you don't want to write this second one down, you don't have to, but pay attention because I at least want to show you what happens. When I go to group the first two, keep that minus sign in, so I'll build in my own plus sign. Now, what do the first two have in common? Just that b. What's left is 5c minus 2. Now, what do these two have in common? I think I screwed something else up. Shouldn't this be a positive? That should be a positive 5ca squared. I'm just making mistakes. What do these two have in common, guys? A squared? Okay, now, here's the thing. Let's check our signs. If I take out a squared, I do keep a negative 2, and I do keep a positive 5c. Did I want that? Well, look, in this one, the 2 is negative, and the 5c is positive. So it's in a different order, but do we see they're the same values with the same signs? If you would have taken out a negative a squared, that would have flipped your signs. All right, now what do these two have in common? the 5c minus 2, or you could have written it as negative 2 plus 5c, same thing. And what's left over? B plus a squared or a squared plus b. Do you see that I got the same answer? A squared plus b, 5c minus 2. The order of what's in your parentheses does not matter. The order of your parentheses does not matter. What matters is that your signs match and the powers match. So we could have arranged this a couple ways. Hopefully you can do better than me because I kept screwing that up. All right, now we should be pretty set for doing E since we dealt with this negative sign. So I'm going to say this again. When I go to group this, there was no GCF. Pair the first two, and here's the problem. If I do this, that minus sign was only on the x, and if I put the parenthesis in here, now it's minus x and minus 1. So this is why I'm stressing the idea, squeeze that minus sign in there and put your own plus sign in. Okay, so now that we've got that set, what's your next step? You're going to take out the GCF. All right, I'm squeezing in my own plus sign. Take out the 3x squared. I agree with you. What's left is x minus 1. Don't forget that 1. Plus, what comes out of here? A 1. You have to take a 1. Now, here's the problem, though. I want a positive x, and what do you have here? So pull out a negative 1, so it flips the signs. So it'd be a positive x minus 1. Okay, what do they both have in common? It should be x minus 1, shouldn't it? And then once we take out the x minus 1, what's left? 3x squared. And you could do plus negative 1, or I'm just going to make it minus 1. All right, take a minute and you try the next one, and then we're going to see if we got it right. There is no GCF, but you need to get in the habit of checking, which is really hard to keep checking when there hasn't been one. I'm going to group it. Group it. Make sure you're adding these because we're not foiling or multiplying. What comes out of the first set? I was going to go with x squared, but thanks for playing. What's left? 2x plus 7. Now, if you look inside my parentheses, both terms are positive, a positive x and a positive 7. So not only do I want to take out a 5, but I want to take out a
7.
I'm going to go with a negative 5. And if I divide by negative, what happens to sign? It becomes a positive 2 with the x and a positive 7. All right, we're back to where we were on the front of the paper. You're starting with these two chunks. What do they both have in common? 2x plus 7. And once that comes out, what's left over? Yep, you can have 1x squared plus negative 5 or just x squared minus 5. So there's definitely work to show, but there are very small problems that you're doing, but there are technical aspects of it.